Shane, is it?
Yeah.
Yeah.
And Matt?
That's right, yeah.
Nice to meet you.
Yeah, you too, man. Yeah. I'm just going to be your tutor for today. So before we start, Shane, are you familiar with object-oriented programming?
Yeah, I mean, I'm aware of what object-oriented programming is. I just haven't really done that much of it. I think we can use like child classes and parent classes to structure our code. And then we can initialize instances of these classes to create objects, is that right?
Yeah, that's correct. So object-oriented programming, it's all about designing software that's flexible, extensible, and that just works really efficiently. So are you familiar with the terms of abstraction, polymorphism, inheritance, and encapsulation? I'll give you a quick overview just in case you forgot. So it's all about really polymorphism, the ability for some object to act as its parent object. For example, we can have a shape, which is like a blueprint for multiple objects, and each one of our shapes, like a square or a line or a rectangle, can be used as a shape, which means we can reuse a lot of code. This is achieved by having inheritance and abstraction. The parent class will be set to an abstract class that is inherited by all of the child classes, which would be the actual specific shapes. And encapsulation is just about how we can control what data is accessed and not accessed within a specific class, what variables that is, yeah.
Yeah, sure.
So whilst these are kind of the basic 4 object-oriented principles, we can implement more specific things to make the software even more efficient. And these are kind of identified as object design patterns or game object design patterns. And I'm going to introduce you to one of them today. That one is object pooling, or the object pool design pattern.
Object pooling. What is that?
So object pooling, it's all about reusing and recycling of our objects. Kind of want to give you a real world example. Think about how we recycle paper. You know, you've just finished year 12, you want to throw out all of your notes that you took in this semester because you don't need them anymore. But when you go to the bin, there's 2 of them there. There's the garbage one, or there's the recycling bin. Now I think most people know to put the paper in the recycling bin, but why do we do that? That's because it can be reused later on. We don't need to use more resources, which is more trees, to actually get more paper. So we can use this exact same principle in programming. We can have a list and a queue. The list would be the paper that you currently have, and the queue is the paper that's being recycled. Eventually, the paper in the queue is going to be reused again. Ideally, then you would never have to make more paper because there's always paper that's being reused.
So how come we need a queue and a list? Couldn't we just send the objects to the back of the list?
So the reason we have a queue and a list, well, I'll explain it in terms of if we only had a list. For object pooling, our list is controlling what's actually visible, and our queue is controlling what's not visible. So if we've initialized 10 bullets at the beginning of our game, but only 4 on screen, then we've actually got 6 in the queue at that time and 4 on the screen. If we didn't have that queue, then you're going to be stuck trying to fit 10 objects onto the screen at that same time. And there's also some good methods that come with the queue type. The main ones are the onQueue and the dQueue. The onQueue, what it does, it adds a object to the queue. The dQueue removes the object from the queue. And that's all relative of an actual queue. Just like in real life, so the onQueuing adds it to the back of the queue, the dequeuing removes it from the front of the queue. Another reason that we do this is because we can make our queue work for maybe your parent class of game object, which means you can reuse this pooling system for all of your different objects that are coming in and out of the game.
Okay, yeah, that sounds good.
That being said though, the paper still needs to come from somewhere, so when our program starts, we actually initialize it with a specific size.
So if we're initializing objects at the beginning as opposed to during the runtime, how many should we actually be initiating?
Yeah, it's a good question actually. The amount of objects that we're going to initialize at the beginning just totally depends on how many we're going to be using at most at one time. I'll give you an example actually. In the game that I'm about to show you, which is a gun that's shooting bullets, probably they might only be able to shoot a maximum of 4 bullets to have on the screen at the same time, which means that we're not actually going to need to initialize more than 4 of the bullets when the game loads at the beginning. If you compare this with what it's like if you don't implement object pooling, you could be actually making up to over 100 objects over time, over the time of the whole game.
And so when an object enters the queue, does this automatically reset all the class variables, or is this something that needs to be manually done?
Yeah, another good question. It's something that I never originally thought about. Once, it leaves the list, goes back in the queue, I was wondering if some specific property about the queue returns the car back to its original form that it was made. Essentially the position going back to, the original position where it should spawn. It doesn't actually. It doesn't do that. So if you didn't implement some kind of method that's going to reset all of the class variables, then when the object moves from the queue back into the list, it's just going to spawn where it left off. Obviously that's not what we want. So usually within our object that's being moved around, within that class we can actually put prepare for spawn or some kind of method along those lines, which will just reset its position to the appropriate position.
So when should we use object pooling and when shouldn't we?
Yeah, sure. So this kind of relates to what I was just talking about. You could probably get away with not using object pooling all the time. Your game is still going to work. When it comes to how well the program works, if you can implement object pooling, for any objects that are going to be coming in and out of the screen, of course it's definitely a good practice to get into.
So does that have an impact on the CPU and memory usage?
Yeah, sure. So I mentioned efficiency earlier. I mentioned that it's kind of the whole purpose of object pooling. It's to be using minimal resources so it's efficient on your hardware. So when it comes to CPU and memory usage, if we can make it so it's reusing objects, it's going to be saving a lot of resources on your CPU and your memory. It kind of is less significant if you're not object pooling a lot of things, and if you're doing it on computer, generally computers can handle a lot of objects on the screen at one time. As opposed to like a mobile game though, mobile hardware is nowhere near as powerful as our computers, which means it's really important that we do implement good practices and good object patterns such as object pooling, because otherwise that's where you get a lot of lag in your games.
So should we assign one per path, or should we assign one to the main that controls all of the objects?
It totally depends on the current situation. There's usually one best way to implement the object pooling. I'm going to show you some examples soon, but I'll give you a quick brief. Basically, in the game where we've got the gun that's shooting bullets, there's really no need to put the object pool actually within the gun itself. We can just put it in main, and any other things that it's going to be controlling can all be done within that one object pool. Whereas in my other example, which is about my traffic controller, we've got so many different lanes of cars, and I wanted to make sure that each lane has a maximum capacity of 10. So I've assigned an object pool per each one of those lanes. You can imagine that if I did it in main instead, each lane could technically be built up forever. Because once it's spawned at a few lanes, they're not, say, all the rest of the cars spawn at one lane, that could go on forever. And I didn't really want that to happen. So yeah, in summary, it really depends on the situation. Okay, so here we've got our Gunman game. I'm just going to give you a quick demonstration of how it works. You can see you just press the space bar and it shoots a bullet. Now, once it leaves the screen, it actually goes back into the queue, so it doesn't exist there anymore. At the moment, we have a maximum size set to 4 in our object pool. So if we try to shoot more when there's already 4 on the screen, it should cause a crash here. There we go. That's a crash. So basically it's trying to grab an object from the queue, but there was no objects in the queue. Now if we go over to our form 1 under our timer, basically when the object leaves the screen, it removes it from the controls. So that just means you won't be able to see it anymore. If I get rid of that though, it's actually going to remain on the screen once it's in the queue. So it should stop once it leaves the screen, which it does. The next one, because there's 4 in the queue, one of them is going to shoot out now. Then the next one is going to grab from that one, the little pile on the right there. The next one is actually going to move that back to the beginning again, as you can see. Now, every time it's shooting a new bullet, if we go to the shoot bullet function here, it is actually doing this prepare for reuse function. Now, the only thing that I needed to prepare for reuse was the position, which is good. Basically, if I didn't have the position being reset, this is what it'll look like. I'll just comment out this function. Because we mentioned it doesn't automatically reset the position earlier, and this is what that looks like. So it goes out of the screen, and then look, it's just going to continue on back from where it left off, which is obviously not what we want. So cool. When it shoots the bullet, it you can see it runs the DQ, which removes it from the pool that we've initialized up here, and when it returns to the pool, we can see it on queues, just like that. Part of the shooting, when it runs this shoot function, it adds the bullet that's passed in through here, rather than creating a new one here. Cool, so basically what I'm going to do is I'm going to put a breakpoint on this leave intersection function. Now this leave intersection function is called when a car gets through the intersection and is no longer used. So as I explained earlier, what it's going to do is it's going to send it out of the path and it's going to put it back into the queue. Now you can see it sets active to false, but the main parts are here. So it goes re-enter pool, putting it back into the queue, and then after it's re-entered the pool, it removes it from the list. Now I'm going to demonstrate it here. Okay, so we'll let this car through with this traffic light. Once it gets to the bottom, it should set off the leave intersection. Yep, there we go. There it is, so we can go step into, and it's just going to call each of these, removes it from the list. I'll just go continue, and you'll notice that it disappears. I'll take the breakpoint off. Quickly, there we go, and as it leaves you should be able to see it disappear there. Yeah, just before it gets out it disappears, which is pretty cool. So do you reckon you could summarize everything that you've learned in this lesson?
Yeah. Essentially the purpose of object pooling is to make your code work more effectively.
Yeah, that's right. Yeah.
And this is done through the use of a queue and a list. When the program starts, the queue is filled up with all the necessary objects.
Yeah, that's right.
Yeah, sure. So it moves from the list into the back of the queue.
Yeah, cool.
Yeah, well this lesson's been really, really productive.
Yeah, I agree. I'm glad that I can, help a fellow programmer learn how to make his code more efficient.